In this video, we're going to finish up the practice problems for our chapter on producer costs. So we'll do practice problems 3 through 5, and that will end our practice problems for this chapter. So practice problem 3, it's going to change the total cost equation for Frye Supply that we've been working with. So now Frye Supply's long run total costs will be equal to quantity cubed minus 60 times quantity squared plus 910 times quantity. Okay, so we'll be working with this new total cost equation. And the first part of this question, part A, asks us to find Frye Supply's long run average total cost equation. So again, average total costs we can find by dividing total costs by output, by Q. So we'll go ahead and do that. So we'll have Q cubed minus 60 times Q squared plus 9 times Q all over Q. We can break this up into separate fractions. So we'll have quantity cubed over quantity minus 60 60 times Q squared over Q plus 910 times quantity all over Q. And from here, we can simplify. So note that the quantity variable in the denominator of each fraction has a 1 exponent, as does the quantity variable in the last term of this equation. And when we have the same base in both the numerator and the denominator of the fraction, we can subtract the exponent on the variable in the denominator from the exponent on the variable in the numerator. So that's going to get us quantity to the 3 power minus 1 minus 60 times quantity to the 2 power minus 1 plus 910 times quantity to the 1 power minus 1. So simplifying, that gets us Q squared minus 60 times Q plus 910. Note that the Q to the 1 minus 1 power becomes Q to the 0 power, which simplifies to 1. So we're left with just 910 in that final term. So our average total cost in the long run is Q squared minus 60Q plus 910. Next, we can move to B. So for part B, we're asked to find Frye Supply's long-run marginal cost equation for given its new long-run total cost. Okay, so part B here. Recall that marginal costs we can find by taking the derivative of total cost with respect to quantity. All right, so that's what we're going to do here. So our first term is Q cubed. We're going to apply the power rule. So we'll have our marginal cost in the long run will be equal to 3 times quantity squared. So we subtract 1 from that exponent. And then in our next term, we're going to use the power rule again. So we'll have minus 2 times 60, which will be 120, times quantity to the 1 power, right after we subtract 1 from that exponent. And then finally, our last term will have that 1 exponent on quantity times 910. So that'll give us 910 times quantity. Okay. And that will be our marginal cost for Frye Supply in the long run. Right. So I can write out that derivation for anyone who wants to see it before it's simplified. So we'll have 3 minus 1. Okay. All right, so you can see what we simplified from. All right. Moving to part C, this is the last part of problem 3. We're now asked over what quantity of output, over what production amount, does Frye Supply have economies of scale? So remember what I said, in the video on economies of scale. Economies of scale refers to that portion of Fry Supply's long run average total costs, where costs are falling more quickly than output. Okay. And once we hit the minimum point of that average total cost, that's when we get constant economies of scale. So what we need to do is identify the point at which Fry Supply's average total costs are their lowest. There is a useful property between the relationship between marginal cost and average total cost that will let us do this fairly easy. And it's that where marginal cost equals average total cost, that is the minimum point for our average total cost curve, right? So all we have to do to solve for the range of production over which Fry Supply has economies of scale is to find the output that that causes marginal cost to equal average total cost. So what we're going to do is, given that we found Fry Supply's average total cost in part A and its marginal cost in part B, we're just going to set those equal. So we'll have marginal cost of 3 times quantity squared minus 120 times quantity plus 9, 10. That should not be there. And set that equal to q squared minus 60 times q plus 910. All right. And now we're just going to solve for quantity. So our first step here is we're going to subtract 910 from both sides. Right? And since that constant value is on both sides, they're just going to zero out. So we'll be left with 3q squared minus 120 times quantity equal to quantity squared minus 60 times q. Okay. And now what I'm going to do is add 120 times quantity to both sides. That will leave us with 3 times quantity squared on the left-hand side equal to quantity squared plus 60 times quantity on the right-hand side. Next, I'm going to subtract quantity squared from both sides. We're essentially just combining like terms with this process. So that means on the left-hand side, we'll be left with 2 times quantity squared equal to 60 times quantity. Next, we'll divide both sides by 2. That leaves us with quantity squared equal to 60. Not 60, excuse me, 30. 60 divided by 2 is 30 times quantity. So q squared equal to 30 times quantity. And then our last step here, we're going to divide both sides by quantity. So that's going to give us quantity is equal to 30, right? And so here we have our answer. Where average total cost is minimized is at 30 units of outputs, 30 servings of fries. And so we know that Fry Supply has economies of scale up until that point. So it has economies of scale for any output that is less than 30, right? Once it hits that 30, it has constant economies of scale. And so moving to D, sorry, I misspoke earlier. We have one more part to this question 3. For part D, it asks over what quantity does Fry Supply have diseconomies of scale? Given our answer for C, we know now that 30 is the quantity at which 30 servings of fries is the quantity at which Fry Supply has constant economies of scale. So once output exceeds those 30 servings, that's going to give Fry Supply diseconomies of scale. All right. Now moving on to 4. Question 4 here, and as well as question 5, will be bridging chapter 7 and chapter 8 for us. And you're going to see a problem on your assignment that is almost exactly like practice problems 4 and 5. Okay, so for number 4, we're giving Fry Supply a new marginal cost curve in the short run of 10 times quantity. Okay, so it's going to look something like this. We are also saying that Fry Supply is one of 100 identical firms in the market. So including Fry Supply, the number of firms in the market is 100. Okay. And 4 asks us to derive the short run market supply curve for fries. So one thing you have to know that we haven't covered yet, and I'm telling you now, to find the short run supply curve, when we're working with identical firms, we're assuming here a perfectly competitive market. We know that price is always equal to marginal costs. Okay, so that is a key relationship in perfect competition. For our supply curve, we know that that's a relationship between price and quantity supplied. Right, so we just need to find an equation that sets quantity in terms of price. Right. So we can start from price equaling marginal cost. Note that Fry Supply has marginal cost of 10 times Q. So right away we have Fry Supply's inverse supply equation. Okay? But note that the question asks us to find the market supply. So currently what I have now is just a single firm, Fry Supply's supply curve. Okay. Because I know that Fry Supply is the same, exactly identical to other firms in this market, we can use Fry Supply's supply curve to aggregate up to the market supply curve. So what we want to do first is solve for quantity, because we don't want Fry Supply's inverse supply curve. We want their regular supply curve quantity in terms of price, not the other way around. So we're going to divide both sides by 10, and that will give us price over 10 is equal to quantity, right? And we can put little Fry Supply, on the quantity term there. So we know this is for Fry Supply. From here, we say, okay, we know that Fry Supply produces 1/10 of whatever the price of fries is, and that's happening 100 times across all the firms in the market. So what we can do is multiply that price term by 100 to get how much will be produced on the market. All right, so 100 times price divided by 10, that's going to leave us with 10 times the price equal to the quantity of fries produced on the market. And that is our answer, right? That is the short run market supply curve for our market for fries. Okay. So 10 times the price of fries will be produced in this market. Moving on to 5, this is our last practice problem. Now we're given Fry Supply's marginal cost in the long run, which are constant at 10. And again, Fry Supply is one of 100 firms in this market. And we're asked to derive the long run market supply curve for fries. And again, this is a perfectly competitive market. So we're going to start from that assumption that price equals marginal cost. Okay, so we have for Fry Supply, it's marginal cost of 10. So we're going to set price equal to 10. Note here that there's no quantity variable. And so this is actually where we stop. So this will be the firms, not the firms, excuse me. Well, it will be the Fry Supply's long run supply curve as well as the market long run supply curve. Essentially what it's saying is that Fry Supply and all the other firms on the market will provide as many fries as consumers want at a price of 10. Okay, so that's what we see. If instead we were to graph Fry Supply and the market for fries in the short run, that's going to look like this. Okay, and so what we're going to see in chapter 8 is that if we add our demand in the long run, right, we're going to have that same equilibrium point where all of our curves intersect through, right? But we haven't yet added demand. Okay, So that concludes the practice problems for this chapter. If you have any questions on these, please make sure to include them in the discussion board. And I will see you all on Thursday.